Hi everyone, good morning. Today we will discuss questions of Unit 1, Part 6. Yesterday also we discussed few questions. Let's discuss some more questions. The unit of length convenient on atomic scale is known as an angstrom and is denoted by a circle is equal to 1 angstrom equal to 10 to the power minus 10 meter. The size of hydrogen atom is about 0.5 angstrom. What is the total atomic volume in meter cube of a mole of hydrogen atoms? Let's start its solution. The radius of hydrogen atom is equal to zero point 0.5 angstrom, which means zero point 0.5 into 10 to the power minus 10 meter. Volume of hydrogen atom is 4 by 3 pi r cube. 4 by 3 into the value 22 by 7 into 0.5 into 10 to the power minus 10 whole power 3. It is 0.524 into 10 to the power minus 30 meter cube. 1 mole of hydrogen atom contains 6.023 into 10 to the power 23 hydrogen atoms. So the volume of 1 mole of hydrogen atom is 6.023 into 10 to the power 23 into 0.524 into 10 to the power minus 30. So it becomes 3.16 into 10 to the power minus 7 meter cube. Okay, meter cube. Then question number next 16. Explain this common observation clearly. If you look out of a window for a fast moving train, the nearby trees, houses, etc. seem to move rapidly in a direction opposite to the train motion, but the distant object, hill, tops, moon, stars, etc. seem to be stationary. In fact, since you are aware that you are moving, these distant objects seems to move with you only. Okay, let's explain this answer. The line of sight is defined as an imaginary line joining an object and an observer's eye. When we observe nearby stationary objects such as trees, houses, etc., while sitting in a moving train, they appears to move rapidly in opposite direction because the line of sight changes very rapidly. Got it? On the other hand, distant objects such as trees, stars, etc. appears to be stationary because the large distance as a result of the line of sight does not change its direction rapidly. Good. Basically, the concept used in this is the line of sight. Line of sight means one-to-one link. Okay. For lesser distance, the line of sight will got changed quickly due to the motion of the train, but for large distant object, it takes so much time. Okay, that's why it doesn't seems to be the distant object seems to be stationary. Precise measurement of a physical quantity are a need of science. For example, to ascertain the speed of an aircraft, one must have an accurate method to find its position at closely separated instant of time. This was the actual motivation behind the discovery of radar in the World War II. Think of different examples in modern science where precise measurements of length, time, and mass are needed. Also, wherever you can, give a quantitative idea of the precision needed. It is indeed very true that precise measurements of physical quantities are essential for the development of science. For example, ultra short laser pulse time interval is 10 to the power minus 15 second are used to measure time interval in several physical and chemical processes. X-ray spectroscopy is used to determine the interatomic separation or interplanar spacing. The development of mass spectrometer makes it possible to measure the mass of atoms precisely. So let's discuss next question. When the planet Jupiter is at a distance 824.7 million kilometers from the Earth, its angular diameter is this one. Calculate the diameter of Jupiter. Okay, let's start. The distance of Jupiter is this one. Okay, given there. It is given there in kilometer. So when we convert this into meter, let's multiply by 10 to the power 3 more and the power got added. Then it becomes 824.7, 824.7 into 10 to the power 9 meter. Angular diameter is given there 35.72 into 4.874 into 10 to the power minus 6 radian. Okay, the diameter of Jupiter D, diameter of the Jupiter is equal to D. Using the relation theta is equal to small d upon capital D. Okay, D small d is the diameter, capital D is the distance. So theta will D will be equal to small d is equal to theta D 824.7 into 10 to the power 9, 35.72 into 4.872 into 10 to the power minus 6. So it becomes 1.435 into 10 to the power 5 kilometer. Next question. A laser is a source of very intense monochromatic and unidirectional beam of light. The properties of a laser light can be exploited to measure the long distances. The distance of moon from the earth has been already determined very precisely using a laser as a source of light. A laser light beamed at moon makes 2.56 seconds to return after the reflection at the moon surface. How much is the radius of lunar orbit around the earth? Okay, let's start with the solution. The time taken by the laser beam to return to the earth after reflection from the moon is equal to this 2.56 seconds. Speed of light is this. Time taken by the laser beam to reach moon 1 by 2. Half will be, it is 1.28 seconds. Radius of lunar orbit is equal to distance between earth and the moon, and it is 1.28 into 3 into 10 to the power 8. So it becomes 3.84 into 10 to the power 5 in kilometers, but it will be 10 to the power 8 in meters. So next question. A sonar, sound navigation and ranging, its full form is this. Sonar, okay, use ultrasonic waves to detect and locate objects underwater. In a submarine equipped with a sonar, the time delay between the generation of a probe wave and the reception of its echo after reflection from an enemy submarine is found to be 77 seconds. What is the distance of enemy submarine? The speed of sound in water is 1450 meter per second. Let the distance between the ship and the enemy submarine be s. Speed of sound in water is given there 1450 meter per second. Time lag between the transmission and reception of sonar wave is 77 seconds. In this time lag, the sound waves travel a distance which is twice the distance between the ship and the submarine. It is 2s. The time taken for the sound to reach the submarine is 38.5. It will be half. Distance between the ship and the submarine, s is equal to speed into the time taken. It will be 55.8 kilometer. Okay, let's discuss some more questions. Okay, Just as precise measurements are necessary in science, it is equally important to be able to make rough estimates of quantities using rudimentary ideas and common observations. Think of the ways which you can estimate the following. Where an estimate is difficult to obtain, try to get an upper bound on the quantity. First part, the total mass of rain bearing clouds over India during the monsoon. Okay, during the monsoon, the meteorologist records about 215 centimeter of rainfall in India. That is, the height of water column is 215 centimeter, 2.15 meter. Area of the country is 3 into 10 to the power 12 meter square. Hence, the volume of the rainwater is V is equal to A into H. It is 7.09 into 10 to the power 12 meter cube. Density of water is 1 into 10 to the power 3 kilogram meter minus cube. Hence, the mass of rainwater will be equal to rho into V, that is 7.09 into 10 to the power 15. It will become kilo in kilogram. Hence, the total mass of the rain bearing cloud over India is approximately 7.09 into 10 to the power 15 kilometer. Part B, the wind speed during a storm. Consider the ship of known base area floating in the sea. Measure its depth in the sea. Say it is D1. Volume of the water displaced by the ship is VB is equal to AD1. Okay. Now Now move an elephant on the ship and measure the depth of the ship D2 in this case. Volume of the water displaced by the ship with the elephant on the board is V D2 is equal to AD2. Okay. So the volume of water displaced by the elephant is AD2 minus AD1. Density of water is D. Mass of elephant will be equal to AD D2 minus D1. Okay. Let's see the third part. What is the wind speed during a storm? Okay. The wind speed during a storm can be measured by an anemometer. As wind blows, it rotates. The rotation made by the anemometer in 1 second gives us the value of wind speed. Okay. So let's see the next part. It is the number of strands of hair on your head. How you can find out this? The area of head surface carrying hair is equal to A. With the help of screw gauge, the diameter and hence the radius of the hair can be determined. Let it be R. A is the area of the hair is equal to pi r square. The number of strands of hair is equal to total surface area upon area of one hair. It is A upon pi r square. Let the volume, okay, next let's see the last part. The number of air molecules in your classroom. Let V be the volume. 1 mole of air at NTP normal temperature pressure occupies 22.4 liter. Okay, that is 22.4 into 10 to the power minus 3 meter cube volume. Number of molecules in 1 mole is equal to this one. The number of molecules in the room of volume V will be find out, and after putting the values, when we calculate this, it will become 1.35 into 10 to the power 26 volume. Okay, sorry, it is 28 of volume. Next question, the unit of length convenient on the nuclear scale is Fermi is equal to 10 to the power minus 15 meter. Okay, the nuclear size obey roughly the following empirical. R is equal to R naught a to the power 1 by 3, where R is the radius of the nucleus, A is the mass, A is its mass number, and R naught is a constant equal to about 1.2 F Fermi-meter. Show that the rule implies that the nuclear mass density is nearly constant for the average mass density of a sodium atom obtained in exercise 2.27. Okay, let's put all the values. R is equal to R naught a to the power 1 by 3, R naught given there, volume 4 by 3 pi r cube. Put the values, find out the V. M is equal to mass, M is equal to mass number, AMU, atomic mass unit, and the density of the nucleus. Put all the values and find out its density. That this relation shows that the nuclear mass depends on only on constant R naught. Hence, the nuclear mass densities of all nuclei are nearly the same. Okay. So the density of sodium nuclei will be given as P sodium is equal to, put the values which are required over there. Then it will become 2.29 to 10 to the power 17 kilogram meter minus cube. Okay, so let's discuss some more questions. Now let's see this. Write SI unit of luminous intensity and temperature. The SI unit of luminous intensity is CD and temperature is Kelvin. Next question. A new unit of length is chosen such that the speed of light in vacuum is unity. What is the distance between sun and earth in terms of new unit if light takes 8 minutes and 20 seconds to cover the distance? Distance between the sun and the earth is equal to speed of light into time taken by the light to cover the distance. Okay, given that in the new unit speed of light is equal to 1 unit, so the time taken is given there 500 seconds. It will be the distance between the sun and the earth will become 500 units. Got it? Next question. Next question. A student measures the thickness of a human hair by looking at it through a microscope of magnification 100. He makes 20 observations and finds that average width of the hair in the field of view of microscope is 3.5 mm. What is the estimate on the thickness of the hair? Magnification of microscope 100, average width given there 3.5 mm. So it's very easy to calculate the actual thickness of the hair. Divided by 100, it is 0.035 mm. Okay, 0.035 mm. So dear students, in this way we considered some questions and try to find out their possible answers. So still, if you have any doubt, then you can ask and try to do the solved examples from the NCERT book. Okay, and try to do questions based on dimension formula, errors, and significant figures. Okay, dear. Okay, dear students. Still, if you have any doubt, then you can discuss your queries with me. Your suggestions are always welcomes. And we are in the closing state of this chapter 2. Okay, so we will possibly start our next chapter, chapter 3, motion in straight line, in next class. So try to wind up this by yourself. Okay, okay, dear students, I'm again telling you to revise this chapter thoroughly. Okay, this will help out you to understand the concepts in a better way. Okay, dear, bye bye.